Atlas 2025, Comet or Spacecraft? Full documentary. A team of Harvard astronomers, while reviewing the latest Atlas project data, detected something that defies normal physics. The object was no longer following its predicted path. Within hours, NASA's Jet Propulsion Laboratory quietly introduced a new orbital solution into its systems, without releasing any public statement. It is true that comets can shift slightly due to jets of gas released as they warm near the sun, but in this case, the variation was far too large to be explained by random natural processes alone. Internal reports began using unsettling expressions: non-gravitational impulse, stepwise accelerations, terms that sound less like the chaos of a wandering block of ice and rock, and more like the control of a spacecraft. The official stance remained silence, but the numbers told a different story. The first warnings did not come from government laboratories. They came from Bill Gray's open-source software, widely used by professional and amateur astronomers. On September 23, the discrepancies between predictions and reality stopped being noise and became a clear pattern. Atlas was ahead of schedule. Its position in the sky was so different from the expected coordinates that the system raised an alert for a possible orbital error. The warning reached the Harvard-Smithsonian Center for Astrophysics. There, using new images from the Magellan telescopes in Chile, astronomers confirmed the anomaly. Atlas was not where it should have been. The magnitude of the change forced NASA's Horizons database to publish an updated orbital solution. The correction appeared quietly, buried among routine daily updates, without any announcement. But attentive observers noticed immediately. Telescopes pointed at the old coordinates found only empty sky. When the coordinates were corrected, Atlas reappeared brighter than expected and clearly displaced from its previous orbit. To the public, there was silence. But inside Harvard, internal bulletins were more direct. Non-gravitational acceleration had been observed. That phrase cannot easily be attributed to simple outgassing. It suggested something far more deliberate. History shows that comets can behave unpredictably. Halley, Shoemaker-Levy 9, and others revealed small measurable deviations, but all of them stayed within the boundaries of known physics. Atlas, however, had broken precedent. The September deviation implied a displacement of tens of thousands of kilometers in just a few weeks. This was not a minor nudge, it was a redirection large enough to alter its perihelion. Even stranger, the data showed not a smooth continuous acceleration, as solar heating would dictate, but discrete impulses, as if someone or something was adjusting its course in controlled bursts. The odds of this happening naturally are close to zero. To reach such magnitudes, Atlas would need to release amounts of gas never seen in its spectrum. The unspoken conclusion was clear: controlled thrusts. Official reports avoided the phrase, preferring non-gravitational impulse. But between the lines, the message was the same: comets do not move this way. October 17 marked the approach to perihelion, but also a critical period. Between October 8 and 18, Atlas would vanish into the sun's glare. For those 10 days of blackout, Earth's telescopes would be unable to track it, and even space observatories would be restricted to protect their sensors. During that window, any maneuver would be invisible. When Atlas re-emerged, it might already be too late to know if the change had been natural or intentional. A leaked Harvard draft summarized it bluntly: stepwise accelerations, incompatible with random outgassing. For an academic report, such words were extraordinary, more like the diagnostics of a spacecraft than the description of a comet. The most striking phrase came near the end: artificial impulse not excluded. Meanwhile, NASA chose a lower profile. In Horizons, orbital parameters were adjusted daily, but without press conferences or official bulletins. To the casual observer, Atlas looked like any other comet with routine updates. But for those following closely, the constant corrections were themselves a red flag. This raised a deeper question. If Atlas really was maneuvering, what was its goal? Was it a deliberate signal, a course correction, or an operation we were not meant to understand? Energy calculations only deepened the unease. A deviation of just 0.1 would require an impulse of tens of meters per second. For a nucleus hundreds of meters across, that translates to gigawatts of power, comparable to the output of multiple nuclear power plants combined. Anomalies in July and August had already suggested 3 bursts of thrust, each releasing the energy of around 10 GW. For a comet, such power is inexplicable. The comparison with SWAN was revealing. Discovered just days earlier, SWAN showed remarkable stability, solid and shaken even under solar pressure. Atlas, in contrast, behaved like an agile body, adjusting its trajectory with precision. Some astronomers began to describe a cosmic tandem: SWAN the fortress, Atlas the maneuverable scout. Different hypotheses emerged. The Explorer probe. Atlas could be an object designed to maneuver deliberately into the solar system. The course correction. September's deviation might have been a calculated adjustment before perihelion. The decoy. Atlas could be nothing more than a distraction, drawing attention while something else happens elsewhere. None could be confirmed, but all matched the data. Institutional silence only fueled speculation. At Harvard, draft articles were held back. At NASA, public statements softened anomalies into natural outgassing. Yet outside, independent astronomers organized under the banner Atlas Watch 2025. They coordinated wide-field cameras, small telescopes, and even amateur radio experiments bouncing signals off the comet's coma. During the solar blackout, every independent measurement would matter, because when Atlas reappeared, the outcome might redefine our view of the solar system: an unpredictable comet, or the first evidence of a deliberately controlled object.